Welcome everyone to the Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist, and our topic this time is Advanced Object-Oriented Programming Concepts. So last time, well not last time, but last month, the last video, a little while ago, we covered some general object-oriented concepts, and this time we're going to hit up a few of the remaining ones that are more advanced. So we're going to cover constructors, destructors, shared members, interfaces, casting, attributes, the static command and how that works, and briefly talk a little bit about memory management in regards to objects. So first, constructors. These are special methods that are called when your object is created with the new command. And essentially, your constructor is a way for you to do initialization on your object. And because of overloading, a concept we learned last time, you can actually have multiple constructors on your classes. And a cool little tip here, if you put a single private constructor that has no parameters on the class, that actually prevents the object from being created using new outside of itself. So that allows you to set up something called a factory pattern, where you can have a shared method, which we'll be talking about in a moment, that can actually create an instance and return it to you. So it gives you just a little bit more control over your object if you want it. And I just want to note that if you're using UI controls, a push button or whatever, and you want to do some initialization on that, you should use the open event rather than creating a subclass of push button and then putting something in the constructor. That makes it a little trickier for you to make sure that all the properties are set up the way you want. And it's possible that something you set in the constructor ends up getting changed by Xojo's initialization code that runs after your constructor. So use the open event for UI controls and you'll be happier. All right, destructors are a bit simpler. There's just a single one, and it's a special method that's called when all your instances, all your objects go out of scope. And you can put cleanup code in there. So if you have specific resources that were created when an object was initialized, you can use this to clean it up. And this would just be for your own stuff. You don't have to, normally you're never going to put anything in a destructor. To be honest, in all the projects and things I've done, I don't think I've really ever used a destructor myself. So they're pretty rare, but they don't take parameters. It's just a method that's going to sit there on the class that can do some cleanup if you have some special needs. And you can't even call it manually. It's called entirely by the framework when the objects go out of scope. And as I said, not commonly used. Shared members. So this can be something on the class that's accessible without an instance. So what's a member? A member is like a method or a property or computed property or something like that. And normally when you create those, you actually need an object. You have to create your object using new, and then you can access the property or the method. But if you create a shared member, shared method, a shared property, you can access it without needing an actual instance. Sometimes they're called class members because they're called right from the class itself. And these members cannot actually access instance members unless you create an instance for them to get through to them, because there's no instance available when you're in a shared method. Particularly, it's a method. A property, regular property won't have code, but a computed property or a method could have code, and they can only access other things that are also shared. Interfaces. Somewhat related to inheritance, they essentially allow you to group related classes without using inheritance. So it's a different way to group your classes. We're going to look at some examples of all this stuff in a moment when we get to the demo part. I'm just kind of hitting the highlights here. So it's a way for you to group classes that are related in some way without having to go through inheritance. And in the interface, you define just the method definitions that are common across all these classes. Polymorphism was something we talked about last time that is essentially a way for things to be used, even though they're not necessarily the same thing. And we'll look at an example of that here, but interfaces can be another way to do that in addition to the inheritance technique we used, or even the event technique that also kind of used inheritance. And another technique you can use with interfaces, and something you can't do with inheritance, is a class can actually implement multiple interfaces. Class can only obviously inherit from a single superclass, but you can tell a class that it belongs to multiple interfaces, and it just has to implement the methods on all those interfaces, and it works. So that this allows a class to be a variety of things. And not, again, interface aggregation is not something that you commonly need, but it is an available technique. Casting lets you refer to an object type as its subclass or interface type. And you can use the isa command to check if an object actually is of the other type, and then you can cast it to the type you want. We'll look at an example of this. It's pretty straightforward, but it's important to note that if you attempt to cast something incorrectly, you can't just do a cast and cast to use the UI controls. You can't cast a push button to be a list box. That makes no sense, and that's not going to work, and you'll get an error. Attributes are essentially compile time properties. They're things you can put on most things that are in Xojo, classes itself, methods, and they allow you to specify some setting that you can, you do this right in the Xojo IDE, and then you can look them up later when your app is running. So you can set a name and a value. And if your value does have, is a literal string, then you make sure you put it in quotes. And then in your code, you can look these attributes up using introspection. Again, attributes are not a super commonly used feature, but can be handy if you're building your own frameworks, or I've used them in a database framework in the past. So we'll look at how you can add them to your classes and methods. There's also a few built-in attributes that you can put on your own stuff to give indication that something's deprecated, or you want to hide it. The static command works like dim. So, when you're declaring a variable, you do, dim person as, new whatever. Well, static replaces the word dim in that structure. And essentially, when you declare a variable like using static, it behaves like a global variable, but it has local scope. So that means you can only use that variable within the method where you declared it using static. But it'll remember its value each time the method gets called. So almost as if it were global in some way, a property. But if you tried to use that variable in another method, it would be out of scope and you'd get a compile error. So kind of an odd little thing, but it can have its uses. And then memory management. Xojo uses automatic reference counting. This is a fast way to manage memory. Another technique that's used in some other programming languages you may have heard of is called garbage collection. And that's kind of a different technique. More like that runs a process that looks around for memory that's available to be freed and then frees it. Whereas automatic reference counting is totally automatic and is faster and just happens immediately. So essentially, Xojo keeps a count of all the references of objects you create. And then those things are released when all the references go out of scope. So the memory is freed. And generally speaking, you don't have to really worry about much. That just works. But you do have to be aware of circular references. And this is a situation where object A refers to object B, and then object B also refers back to object A. So you've got a circular reference there. And there's no way for one of those to go out of scope and there's no way for both of those to go out of scope, because if A goes out of scope if object A goes out of scope, that's great, but object B is going to be still referring to object A, and maybe you no longer actually have a reference to object B because object A had the last reference to it. So you could end up with this one here kind of still this reference still being around and then keeping references there, and that memory just never gets away of your app. So the way to clear that up is to nil things in the right order so that reference counting happens. So let's jump into Xojo and take a look at some examples of these concepts. All right, first one we want to look at here is the constructor one. So I have here a class called person, and when you add a constructor, it shows up under methods. And you add a constructor just like you would any other method. You click method, and then you pick a constructor or type it from the list. And then here you can see I actually have two constructors. I have the standard constructor, and it is just public here. It doesn't even have any code in it. And that's only so I can set it to private later and show what that does. And then I have another constructor here that has parameters, and you can put whatever you want for parameters. So, if you want to make initialization a little easier, you can put in some parameters with some initial values you want to set up in your class rather than, creating new and then setting them as properties later. So you can do something like that. It's entirely up to you. And if you wanted to always force the use of the parameter of the constructor with parameters, you can set the one without parameters to private, and then no one would be able to call the constructor without providing parameters. Go to the right block of code here. So here, first line here, I'm declaring a new object, P1, using person. Now this calls the constructor with no parameters because I'm not providing any parameters here, which has no code, so it doesn't really do anything except create an instance. And then I set the properties manually. And then this one here is calling the second constructor because it's providing the two parameters there. And then those two parameters, as you saw in the code, sets the properties for you. So it's a little cleaner here, one line of code instead of three. You go with a design that works for you. Now, if it turns out you never wanted anyone to do it this way because you were always concerned that they would forget to set these properties or something, you can set this to private. So right now, if I run this and click the button, it'll just add those two to the list. But if I set this one to private and I try to run, I get a compilation error that tells me I can't use this constructor. I can't create an instance using this technique. Now this one's fine because that one is still public and accessible. So that can help you design your classes so that they're used the way that you want them to be used. All right, let's go on to shared methods. All right, so back to person, my go-to class. And you see it still has the same stuff here, but down here, there is now a shared method, which I've just called default. And this is kind of doing the factory pattern a bit here because that is essentially creating a new instance and then returning it. And if I were to make both of these constructors private, your code would never be able to use new with the class because its constructors are private. However, you could call the public default method, which can do this because it is part of the class, so it can access the private constructors. And then you could call the default class to return you an instance. That's kind of an alternative way to create classes. It's the factory pattern is what that's often called, and it can be used if you have something that's creating a singleton where you only want just one instance in memory at any point. You don't want people to create multiple ones all over the place because maybe that could cause problems. So you could implement that using a technique like this. Another technique you could use is have a shared property here. This one here is just an integer counter. And you can actually see here, I put some code in the constructors, and each time an instance of person is created, I'm just incrementing the counter. And it's being a shared property. It's it's always just incremented each time an instance is created. And I could actually add a destructor here and decrement the counter if I wanted, and then I'd be kind of almost monitoring the reference count, I suppose, by myself. Not that that's terribly useful information, but that is something you can do, and you may have a different application for that technique. And you can see you call shared methods by using the class name. So the class is called person. So you do person dot, and then the method name, the shared method name, person dot default. And you can see how that works. So I created 2 instances. So when I asked for the count, it returned 2. All right, last time I showed an example of cat and dog classes and showed how you can use inheritance to do polymorphism so that you could have a simple loop here that calls a method on either the cat class or the dog class and doesn't really need to know which class it is. So here we get the same technique, but it's done using interfaces. So here I have an interface. You can tell by its slightly different icon. And when I expand it, you'll see it has a single method on it. And that's all you can add to interfaces is methods. And you don't put code in or anything. You just put the definition in. And then if I look at these particular classes, they don't inherit from anything, but they are implementing the animal interface. When you add that interface to an empty class, it'll automatically add the interface methods to the class for you. And puts this little comment in here to tell you. And then you can write your code for the interface method. So in the case of the cat class, I want it to return meow, and the dog is implemented also using the animal interface, and we would have it return woof like this. And then the code here is the same code that you have in the other examples I had shown. So we're creating an array as animal. Now animal's an interface, but that's okay. That's a valid type. And then I can add to that interface anything that implements the interface. So in this case, cat implements the interface and dog interface implements the interface. So I can add those to the animals array. And then I can just loop through the animals array. And I can call the speak method that is part of the animal interface. And it will know to call the speak method that's on the appropriate object that's been added. So when I run this, I'll get 1 meow and 1 woof. So that's how interfaces can be used to do a similar function to inheritance. And sometimes they can be used to do something you can't do in inheritance, because you can have any class implement 1 or more interfaces. So, there's all kinds of things here. Some are applicable, some aren't. These are built-in ones that are built into Xojo. But if you would create your own, you could certainly have a class implement 1 or more interfaces as your design requires. All right, casting. So back to the person class here. As you see, that's just a class, has no super. And then royalty is a class, and its super is person. Properties aren't too important here, but you can see standard stuff there. And what I can do here is I can create a variable, call it person, and then I can create a new object called royalty, set a couple properties, and I can assign that royalty to the person variable because royalty is a person. Royalty is a person because it inherits from it. Now, person is not a royalty because you could create a person who is not royalty, but anyone who you create that is royalty is actually also a person based on our design. Now, if I try to come here and call want to display the title for that royalty, that person who is royalty, title's a property right here. So I would think, well, I should be able to call that. I have created a royalty. I gave him a title. I assigned it to person, and now I want to display the title. Well, you get a compilation error here because title is a property on royalty. It's not a property on person. So person doesn't know anything about it. So even though royalty is a person, if it's still in this person variable, it can't refer to stuff that is royalty, such as the title. And that's where casting comes in. All you have to do is cast it. So here you cast it by just using the class name and providing in your reference like that. And now I can access the title property. And if I wanted to make sure that there were no errors, I could actually use the is a command here. So I could say if P is a royalty. And that would make sure that I don't try to cast something that can't be cast. And then which would cause a runtime error. So if I tried to run it right now, I get the compilation error here. And as it says, person has no member named title. So I can comment that out. And then you can see it displays the title that we had set. Now, you don't always need to do the cast. If you don't need to access the specific properties that are in, the more lower level of your inheritance, then you could just leave it in person and not really worry about it. If you're just accessing any of these regular properties. But as soon as you need to access something that specifically is a royalty, then you need to cast it. And this technique works with interfaces as well. Exactly the same thing. You would just check if something is interface type, and then you would be able to call the method on it. All right, attributes. All right, first of all, there's a couple built-in attributes that you can use when you're designing your own code. Now, when you're looking in the navigator, you can see, if you look closely, there's this little red A that appears in the corner of things. That's telling you there's an attribute on these things. So right now, if I click on this, there's an attribute here. Well, where do you see the attributes? They are shown on the Advanced tab in the inspector. So I click there, and I can see the little attribute editor here. And this particular method is using one of the built-in attributes called deprecated. And you can add this attribute to a method that you want to appear as deprecated in the warnings. And then you can have it display an alternative piece of text to say, use this instead of what you are using. And then you can also, if you have a method that you don't actually want to be seen by autocomplete, you can just put an attribute on here called hidden, and then it won't show up in autocomplete. Still be able to call it if you know the name, but it won't show up in autocomplete. Both of these two built-in things are handy if you're designing your own frameworks that other people are using. It allows you to guide things. So if I do an analyze project here, I'll get the warning for these two things here, or for this one, and it tells me that calculate is deprecated. That's this one, and I should use calculate new instead. So that's a helpful thing you can do there. I also, in this case, put an attribute on the class itself, and nothing too specific here, but say you were building a class that maybe communicated with a database or something, and you wanted an attribute that indicated which table in the database it referred to. Well, you could do that with an attribute. And so here I've created an attribute name called dbTable, and I set its value to context. Now, by itself, these attributes you create don't do anything. They're there, they're informational. You could just put stuff here that's informational and never have your code do anything with them if you so wanted. But you can look them up in code using introspection. So here I have creating a new instance of the class that has that attribute on it. And then I'm using introspection to get the information about it. So I'm getting its type information, and then I'm saying, all right, give me the attributes that are on there. So I can call the get attributes method, and that populates an array here. And then I can just loop through it, and I can grab the name and the value. And in this case, I'm just displaying them in a list box. So if I run this, okay, that has some code to show off the methods. If I run that, that attribute that was on that class was read in by introspection and is displayed in the list box. All right, static variable. So you can see in place of dim, the word static is used here to create this variable count. And then the code just displays what its value is, and then it's incremented. And this isn't defined anywhere else. You can see there's nothing else here. It's not like I created a global or anything like that. But when I run this, each time I click the button, that count will have a higher value. Now, again, static is not a commonly used thing. You're not going to want to say, oh, this is brilliant. I'm going to change all my dims to be static because that'll be better. That probably is really not the path you're going to want to go down. But static can be useful for, variables that you set, and, maybe you don't need to initialize every time the method's called. So the static will only initialize them the first time it's called. And then the other times that code could be skipped. So it can be a slight performance improvement in that way. And it also can serve a purpose like this, where you do actually have something that you want maintained throughout different calls of the method. So just kind of keep this one in the back of your mind as a possible thing that you may find useful from time to time. And technically, static's not really object-oriented related. I'm just showing it here in the context here of an object, but you can use it in modules as well. All right, the last thing to show you here is circular reference. So I have two classes here, parent and a child, and the parent has a property that refers to a child, and the child has a property that refers back to the parent. So we have a major opportunity here for a circular reference. Parent refers to child refers to parent. So you see I'm making a little circle here with my cursor. They're both referring to each other. So you can set that up here, create a new parent, set its child property to a new child, and then set that child's parent back to itself. So we now have created the circular reference. And if P1 happened to go out of scope, the P1 thing, which we could do manually here by setting it to nil, then you can see the reference counts here are 2 and 1. This counts as 1 for parent. This counts as 2 for parent, and this one counts as 1 for the child. If I clear P1, I'm now down to 1 for parent, 1 for child, which is great. But I now have no way to access parent. My only reference to it was P1. So I'm kind of stuck here. I don't have a way to access parent anymore, yet there's still a reference to it, and there's a reference to child. So I've got your app right now has a memory leak. You are using memory and you have no way to release it, and Xojo has no way to know either that really situation is something it can clean up. So if you run into a situation like this, you just need to be a little aware of how your stuff is set up so that you can force things to clear in the proper order. So in this case, clearing the child first, resetting that one's single reference, will remove the child reference and its parent reference. So now we're just left with the P1 reference to parent. And when that gets nilled, now both things are down to 0 and there's no memory leak. So your app is happy and not using up the system resources unnecessarily. And like I said, you generally don't really need to even think about this unless you have set up something that is circular in this manner. So just be aware if you do set up things like this that you may want to clear things out appropriately. All right. So you can always download the latest version of Xojo from xojo.com/download. And today is August 7th, and Xojo 2018 Release 2 came out this morning. So if you weren't aware of that, head on over to download and grab the new version and check it out. Read through the release notes to see what's new. If you're just starting out with Xojo, be sure to check out xojo.com/learn and grab our free Introduction to Programming book. As always, take advantage of the user community at forum.xojo.com. Ask questions or just use it to search for answers, which I know a lot of people do. They just lurk around there, and when they run into something, they tend to head over there and search and end up finding their answer and never even had to have asked the question. And of course, you can learn more at the Xojo Dev Center, developer.xojo.com, which has a full user guide, videos, lots of other tutorials and quick starts and things to help you get some practice and learn how to use Xojo efficiently. You can always reach me, paul@xojo.com, with any questions. And I'm also on Twitter, @Lefevre, and the official Xojo account on Twitter is @Xojo. You can always tweet us your quick little questions or thoughts. Of course, Twitter has a limited ability to respond as far as length of answers and things like that. So it's good for short little questions, but you're always welcome to email me if you got something lengthier you want to ask. I want to thank everyone for attending. Have a great day.